Now we are going to start with the compounds of carbon. As you know that carbon just exhibit different properties, that is why we get to see the different numerous compounds around us, right? So that means for now it's a time to focus on the compounds of the carbon, right? So there are many compounds of carbon, out of which the class which is very important, or you can say the compound which is mainly found, is hydrocarbon, right? Before I just start you with hydrocarbon, the one thing was striking in my mind. It was just disturbing me, because I want to tell you, it is so excited to know that, you know, that earlier it was actually this thing believed that we cannot synthesize organic compound in a lab. We found only organic compounds in the living ones, that is the plants and the animals. But the Frederick Wöhler was the volunteer who just gave blow to this theory. And actually, you know what was that? The theory was the vital force theory. What does that theory stated? That theory stated that they require a mysterious kind of force. That means there is an existence of different kind of force which is just possessed by the living ones. That is why they can just form those carbon compounds in themselves. But that mysterious force cannot be obtained, or we cannot have in a lab. That is why it is just impossible to make an organic compound. But actually it was false. You know that the Frederick Wöhler was a scientist who gave a blow to this vital force theory by accidentally forming a organic substance in a lab, right? So this is a great achievement. So just let's see that what he did and what kind of compound he accidentally formed in a lab. He was actually reacting the ammonium sulfate with potassium cyanate, which what results into the ammonium cyanate plus potassium sulfate. This was formed, right? Then what he did, he just heated this ammonium cyanate. Then what he get? The just reactants got rearranged, and they just leads to the formation of this. And you know what is this substance? Yes, you are right. It is a urea. So it was the first organic compound which was synthesized in a lab. And though you can say the synthesis was a accidental synthesis, but still we know that it just proved that we can. It is not like that there have to be a mysterious force for synthesizing this organic compound. That means the synthesis of organic compound is something you can say can be done in a lab as well, right? So this is an important thing. You should remember it, and it is interesting too, because see, sometimes when somebody just proves something or some fact, or just you can say just makes some theory wrong, it is a great achievement. So that you should just know that and you should just keep it, or you should remind it for a longer period. It's a great achievement, right? So it is the first compound which was synthesized in the lab, that is the urea, right? So I just told you because it was striking my mind, that's why. Now coming to the main category of the organic compound, that is the hydrocarbon, right? So now what is this hydrocarbon actually? Hydrocarbon are actually the class, you can say the class of organic compounds which are mainly comprised of hydrogen and carbon, right? The main components of hydrocarbons are carbon and the hydrogen, right? They may contain some other atom also in traces like NO or something like that, but the two components which are necessary in hydrocarbon is the hydrogen and the carbon, right? So it is that, the hydrocarbons, right? Now, as you are familiar that what is the basic category of the numerous compounds which are found in the nature, the basic component, that is the hydrocarbon. But before we take into the consideration the detail of the hydrocarbon, you should know that what kind of structures do they form, right? So they, depending upon the structure, they are just divided into different categories. The aliphatic group. That means the aliphatic, you can say the chain structure. As I told you, carbon can link in different ways. It can form the chain, the straight chain, it can form the branch one, it can also form the ring-like. So likewise, I am just dividing them into the different kinds. It can form the aliphatic compounds. It can form the alicyclic compounds. It can form the aromatic compounds. So it can form three different kind of compounds: the aliphatic, the alicyclic and the aromatic. I'll just draw the compounds for you, then it will be clear in your mind what I'm talking about. Right. So aliphatic is like that. suppose there is a compound, suppose I am taking an example, butane. And from where this butane has come, you'll know with time, as I'll start the topic, you will yourself be able to make butane, ethane, methane or alkene, or so just don't get confused. I'm just listing the examples for you. Then I'll make you learn that how you can form these compounds. It's just so simple to do that. So just for this moment, just look at the examples. So what I'm going to just make you understand is that when I write the structure of butane, it comes out to be like this. So when you can see the structure like this in a chain, that means it belongs to a aliphatic compound, right? Similarly, if I write in this manner, which is said to be ethene, then also it is an aliphatic compound. So whenever you get to see this open chain like structure, that means it belongs to a aliphatic category, right? And what is this alicyclic ones? Alicyclic is that, like I'm just making this chain. So what is there? There are 3 carbons forming a triangle. These are 4 carbons forming a square, right? So similarly, I can form the hexagon as well, right? So these compounds in which we get to see a cyclic structure, they are alicyclic compounds, right? And what is this aromatic one? Aromatic is that in which at least one benzene ring is present. Now the question must be arising in your mind that what is this benzene ring? We are familiar with the carbon, from where does we have got this benzene, right? So benzene we'll study later, but still for a moment I'm just making you familiar with benzene, what actually it is. It is a member of again a 6 carbon arranged in a hexagonal manner with 3 alternate double bonds and with H to satisfy the valency of C. So this is a benzene, right? So that means I think you understand. I don't want at this moment, I don't want that you should know that what is the structure of butane, how to write it. I just want to make you familiar that what according to the structures we get different compounds, right? So these are the aliphatic, which falls under the category of open chain compounds. As you can see, there is no nothing like that. They are just open chain. So that they belong to a category of aliphatic compound, and they include the category of closed ring-like. As you can see, there exists a ring between them. So they belong to the alicyclic compounds. And when I talk about the aromatic, that means it includes at least one benzene ring. And moreover, we can also categorize into more to the cyclic ones, as they are closed ring. So they belong to a category of cyclic one as well. So they can just be classified into 2 categories: homocyclic and heterocyclic, right? Homocyclic is that in which the cyclic ring contains the same kind of atoms in it, right? And the heterocyclic is one in which along with carbon and hydrogen, there are not all the elements present. There is some element present which is different from them, like this. I can make this for you. So if I have a structure like this, so you can see there is an O between them, right? It can be replaced by N, H, S, anything. So which has not all the carbon atoms similar in it, it has some other kind of element also present in it, then it belongs to a category of heterocyclic compounds. I think it's clear now that the compounds can be aliphatic, the open chain can be closed ring. Open means a straight chain and the closed means they forming a ring. They can form a ring either in this way or in this way. Homocyclic, if ring contains the same kind of atoms. Heterocyclic, if the ring contains the different types of atom, that means it also possess along with the carbon and hydrogen some other element as well. So it belongs to a heterocyclic category, right? Now we are just going to study about the detailed information of the hydrocarbon. What actually are the hydrocarbons and how we are going to categorize that, right? That is an important aspect of this chapter, because once you will start with the chapter, the hydrocarbons or the structures, they actually serve as a tool to the organic chemistry, right? So I am writing hydrocarbons because now we are just considering on the hydrocarbons, right? Hydrocarbons, as you know, they are the compounds of carbon, hydrogen, may contain oxygen or some other element in traces, but the main constituent is the carbon and hydrogen, right? These hydrocarbons are categorized into 2 categories: saturated and unsaturated. right? Now, what is the saturated and unsaturated? If there is a single bond between carbon and carbon, that means if we see a chain and there is all single bonding done between carbon atom, that means it belongs to a saturated group, right? What is this unsaturated? It may contain, if a chain contain minimum one double bond between the carbon, that means it belongs to a category of unsaturated. It may contain more than one double bond, but minimum condition required to be unsaturated is that the one minimum double bond should be there. Or it may possess minimum one triple bond. So they also belong to a category of unsaturated compound. So that means if there is all single bonding done between the carbon atom, it belongs to a category of saturated compounds. If it possesses minimum one double bond or more than one can also be there, it belongs to a category of unsaturated, and similarly the triple is the subcategory of the unsaturated, right? So this is how we divide them. Now there are the special names for the saturated and the unsaturated. Saturated are called as alkanes, right? The unsaturated compound with minimum one double bond or more double bond are called as alkenes, and similarly the triple bond ones are called as alkynes. So these are the, you can say, the main names which are given to the category. That is, the saturated one is the only alkane, unsaturated one is the alkene with the double bond, alkynes are with the triple bond, right? Now, as we know, they belong to a different category, that is saturated, unsaturated, alkane, alkene, alkynes. So that means their name should also end with a certain, you can say, the suffix, the certain ending. Ending means the suffix, the certain ending, so that by looking at the name you just can make out that what category it belongs to. Like I say, butane, right? So butane, what is the suffix for the butane? A-N-E, ane, which resembles the alkane. That means it belongs to a category of saturated compound. So that means we need a certain thing that we should not, by just listening to the name we can make out that which category it belongs to, right? So what is the suffix used for them are, for alkanes we use suffix ane, right? For alkene we use suffix ene, and for alkyne we use suffix ine. So if the name of any hydrocarbon ends with ane, so obviously it belongs to a category of alkane. If it ends with ene, it belongs to a category of alkene, and if it ends with ine, it belongs to a category of alkyne, right? Likewise, we have a general formula as well for them. The general formula which is obeyed by all alkanes is CnH2n plus 2, right? And for alkene it is CnH2n, and for alkynes the general formula is CnH2n minus 2. Now the question must be arising in your mind that C is clear, H we know is that, 2 is okay, but what is this N is? Like I have written N in all these equations, that means what does this N specify? So I just want to tell you that this N indicates the number of carbon atoms linked in a chain. This N specifies the number of carbon atoms that are linked in a chain, right? Now I'll be forming the, you can say, the examples for them, then you'll be able to understand what is this N and where does it comes from, right? Now before I just tell you to make an example or how to make an example for it, you should know that this N, what is the name given to this N in the chain? Right, so N is indicated by the word root, right? N is indicated by the word root. Word root is actually, you can say, a thing which just guides us, or you can say which just states the number of carbon atom in a chain, which is indicated by the N, right? Like if a chain has only one carbon atom, that means word root is 1, then the word root which we use for one carbon atom is meth. Similarly, if a chain includes 2 carbon atoms, we use the word root eth. If it includes 3, likewise we use prop. For 4, we use but. For 5, we use pent. For 6, we use hex. For 7, we use hept. For 8, we use oct. For 9, we use non. and for 10 we use dec. We can have more than 10 as well, right? But for you, for your standard, you should remember at least 10, right? So this just word root, what does this word root indicate? This indicates the number of carbon atoms in the chain, that is, it indicates the N, right? So I think it's clear, like if it's 1, then meth, eth, prop, bute, pent, hex, hept, oct, non and dec, right? So this is how we are just going to use, instead of like if a chain has 2 carbon atom, I am not going to say that 2 carbon atom, I want a word which should specify that yes, it's a 2. By looking at the name, I should know that it contains 2 carbon atom. So what in that case we are going to put? We are going to put eth, right? So I'll just say ethane. Like if I say ethane, what information do you get from this ethane? Eth means 2 carbon and ane means alkane. So that means it is a member of alkane with 2 carbon atoms. So this is why we have the word roots. I am telling you the word roots because by looking at the word we should get the complete information that which category it belongs, how many carbon it possesses, or many more properties which are linked with it. You will get to know later. So this is how the word root plays an important role. It is a just tool to a naming kind of thing, that is IUPAC, which we'll be taking in the later sessions, right? But now for this moment I want that you should know that how to make these alkanes, how to make alkenes, and how to make alkynes. Like I took an example for butane. I told you that time that it is not a big deal. It's just so simple and you just need to use certain tools and you can make that structure, right? So just look at the board how to make that. Like if I wish to make the structure of alkane, what I'm going to do, see, the minimum number of carbon atom we are starting with will be the 1. Right. For 1 carbon atom, what word root we use? Yes, you are right. We use meth. So the name becomes meth. And as I am making the member of alkane, I know the suffix uses ane. So the name becomes methane. Methane means, meth means 1 carbon, ane means single bonding. Look at the board how I am making. Meth means 1 carbon atom, right? There is nothing present, no other carbon atom, nothing is present, right? Because the meth indicates only 1 carbon in a chain. So I have just wrote 1 carbon, right? Ane means it has the ability to form only single bond with the other carbon. As there is no other carbon in the chain, because meth means 1 carbon, so this ane doesn't play an important role in this, or you can say we don't have to use this. It is no logic to use something like here because there is no other carbon atom, right? And as I've told you that carbon is tetravalent, it has 4 valence electron, or you can say it needs 4 electrons to stable its noble gas configuration. So what it is going to do it, how we are going to stabilize it. So if it is in our hand, we can use as much as an hydrogen atom which is necessary to the carbon to complete its octet, right? So in this case, how many hydrogens are required to satisfy the valency of carbon? Yes, it is a tetravalent. There is no other carbon atom or any other atom which is satisfied the valency of carbon. So that means in this case we are going to put 4 hydrogens. So likewise, I have put 4 hydrogen. So that means carbon already has 4 electrons and it also shares the 4 electron of hydrogen. This is the open formula. If I condense it, so it is 1C and 4H. So this is the formula for the methane, right? Now, likewise, I'll make a member, for example, I'll make a 4th member for you. When N is equal to 4, I know that what word root I use bute. So the name comes out to be bute. As it is a member of alkane, so name becomes butane. You know where this butane is used? It is a main constituent of the LPG, the liquefied petroleum gas that you are using in your kitchen contains the main constituent, that is the butane, right? So again I am making the structure for butane. Bute means 4 carbon, right? Ane specify all single bond between the carbon ones. So I've just put all single bond. And we know each carbon is tetravalent. So what I'm going to do, I'm just going to satisfy the valency which is left unsatisfied by putting the hydrogen. So in this case, how many bonds it has already made? No bond, no bond, no bond, but 1 bond, right? So how many valence electron it needs more? 3, right? So I've just put 3H along with it. See, now its valency is complete. 1, 2, 3 and 4. No matter with which carbon is making a bond, we just need to satisfy its tetravalency. So now its valency is stable. Now we look for the second carbon. 1 and 1. 2 valencies already satisfied. We are just left with 2 unbalanced valencies. So I have just put 2H, because H is in our hand, we can put as many as H, we would just want to satisfy the carbon atoms, right? Similarly, 2H, because 2 are satisfied, and again is the 3H. So this is the open chain structure. But when I'll condense it, what I'm going to get, I'm just going to count all C's together and all H together. That is C4, 1, 2, 3, 4, and H, 3, 4, 5, 6, 7, 8, 9, 10. So this is how you are going to make the alkanes. If while making the alkanes, if problem persists in your mind that yes, or if you have a confusion that whether this butane is correct or not, so here the general formula works for you. Like as I told you, the general formula for the alkane is CnH2n plus 2, right? You know that. And if I ask you to make the member of butane and you know that but means 4, just put the value n as 4, just look at the formula. I have just put n as 4, n is 4. What do I get? C4H10. So, if this formula which we solve from the general formula comes out to be similar with the structure you have made, that means you are correct, you are on the right path. So, this is how the general formula works for you. I think it's clear how to make alkanes now. So, likewise, you can make methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane and decane depending upon the number of carbon atoms in a chain, right? So alkanes, we are done with it. We know that how to make alkanes, what are the general formula for the alkanes, you are well versed with it, right? Now we are taking into the consideration that is the alkenes. Again, n is equal to 1 specify meth. The meth and the suffix we use is for alkene is methene. So the first member of alkene is methene.